This is just a quick video to describe what happens whenever we differentiate a functional. Now if we have a function of the form L equals a function of x, y and y derivative, then if we were to take the derivative partial L by partial x and the derivative partial L by partial y and partial L by y derivative, then we would do the partial differentiation as usual. So partial L by partial x, we would have y and y derivative would act as constants, and partial L by partial y, the x and y derivative would act as constants, and partial L by partial y derivative, then the x and y would act as constants. Okay, so you've probably seen that before if you've done some partial differentiation. Now the couple of identities here, the first one you may have seen before and it's kind of self-evident. If we were to take partial x by partial x equals partial y by partial y equals partial y derivative by partial y derivative, these are all going to give you a value of 1. Okay, now again that's kind of self-evident just from basic calculus. Now if we were to then look at these other identities here, now there's only really 3 here, that each one has got a reciprocal. So partial y derivative partial x has got the reciprocal of partial x by partial y derivative. Okay, so the reciprocal is going to give us the same answer. Okay, now the answer to each of these is going to be equal to 0, and you can see that from above. If I was just to have a look at one of these in particular, so if I was to look at partial y derivative by partial x, well, whenever I go up here and we look at partial L by partial x, well, when we take partial L by partial x, y and y derivative act as constants. Okay, so that means if I was to come down here and I'm differentiating with respect to x, but the y derivative is just equal to a constant. Okay, so that means we're differentiating a constant with respect to x, and when you differentiate a constant you just get the value of 0. Okay, now you could take another one as an example, partial y derivative by partial y. We're differentiating with respect to y. If we differentiate with respect to y, then the value y derivative just looks like a constant. So if the value y derivative just looks like a constant, then we're just differentiating a constant with respect to y, which will just give you a value of 0. And the same will occur for the reciprocals of each of them as well. Okay, so that's a little bit of identity that you need to take note of whenever you're working through and differentiating in terms of differentiating a functional. Okay, so here's an example here, and again this example will crop up later on in videos in the future, so I just picked it out as a little example. And you'll notice that this same sort of thing occurs in the next few videos. Okay, so if we had a function here, partial or partial y of a product of 2 functions, so some function p of x, so it's a function that's p which is a function of x, and the function y derivative, then we would, in order to work this out, we've got a product of 2 functions, so we just got to use the product rule for differentiation. So it's going to be differentiating u times v, it's going to be u dv plus v du. Okay, so in this instance here, we differentiating p of x with respect to y. Okay, so you get partial by partial y of p of x. Okay, and then you're going to multiply it by the y derivative. So this is differentiating that term, multiplying with y by y derivative. And then the second part of it is we're going to differentiate y derivative with respect to y and multiply it by the function p of x. But from above we note that this partial y derivative by partial y, that is going to be equal to 0. Okay, because whenever we differentiate with respect to y, the y derivative acts as a constant. Okay, so I'll come up here. When we differentiate with respect to y derivative, the value of y just acts as a constant. Okay, so it means that this whole value here, partial y derivative partial y, it's just going to give you a value of 0. So that whole term is going to disappear. So all you're going to be left with is partial p by partial y times y derivative. Okay, I've not put in that x there, it's kind of understood that p is a function of x. Okay, so that's just a quick video just to show you some basics of differentiating or the functionals. Okay, thank you for listening and goodbye.